Hey, my name is Brant Wagener. Clearly, I'm growing a beard again now that I don't have to wear a mask 100% of the time. I'm here today to talk to you about a career in critical care research, or critical care and research. I'll be very quick. I'm not gonna share any content. I just have some notes, so you'll see me looking sideways occasionally. I'm a physician scientist at UAB. I figured it best to give you a little bit of my own perspective of how I got to this point, and then also give you an idea of the biggest questions inside anesthesiology and a prescription of what you might be able to do, although its application may be more challenging. So where I started at the University of New Mexico in Albuquerque. I was an MD PhD student. Initially, I was going to save the world. I had a breast cancer research fellowship from the DoD. I was working in a lab that worked on GPCRs and cancer metastasis, and I had the idea that was going to stop breast cancer metastasis. Got my funding, got started, immediately got derailed by the results. My experiment didn't work, and troubleshooted it for a few months, could not kill these cancer cells. So at that point, I made a choice to broaden my scientific focus and decided that during my graduate work, I would learn as much as I could about G protein coupled receptors because, as you probably know, they're everywhere in the human body. And also, it was a good time for me to learn how to be a scientist, how to troubleshoot experiments, how to write a paper versus write a grant, how to interpret data in a way that is honest and doesn't serve my needs, but tries to reflect the truth of what is going on. So how did I choose anesthesiology? Well, from my science, I decided that since GPCRs are everywhere, I would just learn about them. I would go back into medical school, do the best I could, find a place where I wanted to be clinically, since I might need to use it as a golden parachute someday, if research didn't work out. And then I would be able to find the GPCRs from that. Initially, my wife wanted me to be a radiologist, and that wasn't going to happen because there's not a lot of research with that unless you're doing Hounsfeld units with something. I thought about being a surgeon. I really liked the way surgeons think. I liked the way that they were able to correct a problem, that they would take action on things, which is not always to everyone's benefit, but it does have a good thing. Then I met a vascular surgeon, and there were two of them. And basically, I realized that they had to be in clinic and round on patients afterwards and do the operations and everything else. And they were telling me that I would be able to do research as a surgeon. And I straight up asked them how they would do research. And they said, well, we just work on it after we do everything else. You know, we have like 18, 20-hour days. They then came to realize that one of them was never going to have a family by their own choice. And the other one was divorced and was basically exiled from his family. So this was not an option for me because I already had a wife. I was going to have a daughter soon. I wanted to do that. But anesthesiology, as you guys all know, is awesome. You have a large spectrum of care. There's multiple ways to help patients, be it pain, preoperative stuff, postoperative care, taking care of them in the OR, doing echo. There's a myriad of ways in which you help out. But one thing about anesthesiology, and why I chose critical care, is because I liked helping longer than one episode of care. So instead of just taking them to the OR, getting them off to sleep, keeping them happy while they're asleep, taking excellent care of them, and then getting them back awake and out of the PACU with a good result, I wanted to have care that's a little longer than that. So how to get involved in critical care? Getting involved in critical care is relatively easy. If you guys don't know, generally there are more fellowship slots than there are applicants every year. So getting involved in critical care should be the low-hanging fruit out of this presentation. However, I will advocate for critical care even if you decide not to do it. You definitely have rotations in residency that you have to do. Do your best job and learn as much as you can from that. Take advantage of what there is to learn. You will run into patients who are septic in the OR. Obviously, choosing levofed rather than phenylephrine is probably a better choice for that patient. I mean, you need stress dose steroids. It's good at teaching you resuscitation, a variety of things. Even when I was a CA3, getting ready to go into critical care fellowship, I had a couple of different attendings tell me that they wish they had paid more attention to their critical care training and residency, because it would make them better doctors in the OR. And like I said, there's a lot of other things to learn. We do amazing things with echo and a variety of things beyond that. So the simplest thing to do is find a mentor, see if you really like critical care, realizing that the job you may do as a resident in the ICU with a lot of notes and things like that is different than the one that you'll do as an attending, which may change your mind as well. Next, how to get involved in research. Your best thing, start early, okay? And it doesn't have to be big. Look for writing opportunities, okay? If you get involved in writing a case report, helping write a review, writing a paper, writing a proposal for an IRB, it doesn't matter. If you decide to do clinical research, starting that IRB early is going to be highly beneficial to you. The reason I say that you should learn the writing is because the writing that is involved in research, and even research itself, is a skill that is learnable by anybody. And also, once you start to write, for example, I'm writing a review with a couple of students right now, they have to go and read the papers before they can write the paragraphs that become the review. That means that they learn about their research and learn about a variety of things that they didn't know before. One of the things that my PhD only colleagues, even they who have full-time research labs, moan about is their inability to read and keep up with the literature. That's not going to get easier once you start adding clinical work into it. But when you write and you have to write a discussion for a paper, or you're writing a grant and you have to read somebody else's literature, it becomes a learning opportunity, which will then broaden your horizons and broaden your questions. That's the other thing. The last thing about getting involved in research: be creative, be broad, but then stay focused. So it's very easy to figure out a very broad question like, how does a particular phenomenon happen? And that's fine, but that's not where you can start. That's not even where I can start as a funded researcher. Okay, I can start there, but you have to focus in on your question and create a testable hypothesis that then you can carry forward and find an answer to. And it doesn't always matter that the answer is right or wrong or match what you said. That's where then if your answer doesn't match what your hypothesis is, that's where you go back to the literature, figure out why it differs, and you come up with a new creative hypothesis, publish that first work, and then move on from there. The last thing is finding, or before we talk about topics, is finding a good mentor. Keep in mind that finding the most famous high position person in your department is not necessarily always the most helpful. Trust me, I have those guys in my department and I love them, but that doesn't necessarily mean that they have time to properly mentor a medical student or resident. Or it may be that they have really great postdocs that can do it. Or you find a mid-level person that has time and cares to mentor. And it's not that people don't care to mentor usually, it's just that they have sometimes so much else to do with administrative stuff and meetings that they don't get to focus on that. And frankly, I think some of them don't like that. So find people that are productive, willing to work with you, and willing, like I said, to do a small case report or whatever else, and then be energetic, do your side, and then it'll force your mentor to do their part, and both of you will learn something from it. So topics that I work on, my biggest question is, how does acute critical illness become chronic critical illness? So for example, when you get really sick in the ICU, whether you get ARDS, septic shock, AKI requiring CRT, anything like that, a significant number of those patients will die in the ICU. But once they get past 20 or 30 days and they survive and they go out to the floor, it turns out that they've survived the acute critical illness, but over the next, say, 1 to 3 years, roughly half of those people will die of more pneumonias, critical illness, polyneuropathy, cognitive dysfunction. There's a variety of long-term issues that happen. So the question is, what's going on in the ICU and what's going on in the acute setting that leads to this chronic problem? Because as you can imagine, it would be a huge economic burden. It's a burden to the patient's lives, to their families, things of that nature, which is an important question to answer. But you can't answer that broad question, so then you answer the small questions within it. So different ways that it starts. If you get this chronic critical illness, if you can get it from ARDS and from septic shock, are those separate entities? Do they have separate molecular paths, or do they share things that are in common? There's lots of pathophysiology and mechanisms. You can look at the short-term outcomes, like renal recovery if you were on CRRT, or you can look at long-term outcomes. What is their cognitive function like after 5, 8, 10 years? Does it ever recover? Does that patient ever get back to where they were before? You can also look at potential therapies inside that. So can you treat the patient after they already have the chronic critical illness? Or do we have to intervene at a very early stage, like when they first have their pneumonia that leads to their septic shock? Otherwise, there's not a lot that we can do. And I do a lot of basic translational and clinical research involving that, with a lot of collaborators, a lot of help, and techs and students along the way. Then other topics that are part of critical care research, this is where you use your imagination, because there are lots of clinical phenomena. How do things happen? Why does pneumonia sometimes lead to septic acute tubular necrosis and acute kidney injury? People will say that it has to do with cytokines and things like that, but that's a broad answer. What are the specific ways that it happens? There's also lots of mechanisms. For example, ARDS and sepsis, they're both syndromes, but our clinical trials, we treat them as though they're specific diseases. And frankly, Carolyn Calfee has been publishing on this, but the ARDS that you get from trauma and hemorrhage is molecularly distinct from the trauma, or from the ARDS that you get from pneumonia. So does that mean that even though they both lead to ARDS, they lead there in different ways? And if you were to use specific therapies in one group of patients and specific therapies in another, that you would get better outcomes. The same thing for sepsis. E. coli sepsis is probably different than Pseudomonas sepsis. It may be different in people with different comorbidities, age, race, sex, name it. This is where we're also getting into, in the ICU and the OR, getting into machine learning and to artificial intelligence, because there's just huge amounts of data to be able to figure out which groups are doing what. And so if you figure out the molecular endotypes of some of these syndromes and mix it with big data, you may get answers so that you know, for example, if you're a 45-year-old white male with no known comorbidities who's maybe a little bit overweight and he gets a Pseudomonas pneumonia, that he needs a specific therapy compared to his 42-year-old Hispanic wife who is not overweight and has like a touch of asthma, and she gets an E. coli sepsis, that we get different therapies that will both improve our outcomes down the road. Even forgetting that those are individuals, we both fall into specific groups. Like I said, male versus female, white versus Hispanic, things like that. And that's where I think precision medicine is going with this as well. So I hope in my 10 or 12 minutes, I've been able to give you some generalities of things that can happen with critical care and research. I will stay on as long as you guys like after everybody else has finished speaking to answer questions. And I look forward to hearing what you guys have to say. Thank you very much. Bye.